Hi, my name's Alec Tubbs, and this is my Lab 3 report. The main purpose of this lab was to determine the magnetic dipole moment due to a small cylindrical magnet. We also calculated the net magnetic field, a distance r, 45 degrees off axis from where the magnet was located. I found the magnetic dipole moment to be 6.69 amperes meters squared, and the 45-degree value calculated experimentally I found to be 6.82 times 10 to the negative fifth Teslas. Knowing these two values, I created a program in VPython to calculate the expected value given the same magnetic dipole moment and same distance r. The 45-degree value that I calculated using GlowScript was 8.07 times 10 to the negative fourth Teslas, which is a lot bigger than the value that I calculated experimentally. The main physics concept at play for this lab is the idea of magnetic fields. More specifically, the idea that a bar magnet has a north pole and a south pole and creates a magnetic field that points from the north pole to the south pole. The uppermost equation to the right, gives the value of this magnetic field. If we have an observation location on axis, the dot product mu naught dot r hat is just going to be mu naught, so that the magnitude of the magnetic field on axis is mu naught over 4 pi 2 mu over r cubed. However, if we're looking at a location perpendicular to the magnet, the dot product mu dot r hat is just going to be 0, so that the magnitude of the magnetic field perpendicular to the magnet is mu naught over 4 pi mu over r cubed. Another physics concept at play for this lab is the idea that the Earth essentially acts as a bar magnet with a north pole and a south pole, so that anywhere you are on the Earth, there's some sort of magnetic field. In the experiment, a magnetometer app was used to determine the distances needed for certain corresponding magnetic field values in microtesla. I positioned my phone in a way such that the x component of the magnetic field due to the Earth was 0. This way, when collecting the data, we could neglect the magnetic field of the Earth. I then located the position of the magnetometer in my phone in order to get the most productive results. In doing the experiment, I noted that while the magnet was far away from my phone, the x component was near 0. Meanwhile, if I moved the magnet closer, the magnitude of the x component got larger. The data I collected is shown in the screenshot of the spreadsheet to the left. The ultimate results of this are that I calculated the n to be negative 1.55, which is about half of the expected value of 3, and that I found k to be equal to the natural log of negative 13.524. Using this, in the picture to the right, I show how I calculate the magnetic dipole moment. I ultimately found this to be 6.69 amperes times meters squared. The last part of the lab was the coding portion. The first step that I took in the coding portion of the lab was to write a function to calculate the magnetic field. This function is shown in the bottom right of the screen. Using this function, I calculated different magnetic fields from different observation locations. The results of this are shown in the picture in the bottom left. As expected, as the distance between the magnet, which is represented as this white cylinder thing, and the observation location, as that distance increases, the magnitude of the magnetic field decreases and the arrows become smaller. The final part of the coding portion of the lab was to calculate the expected magnetic field a distance r 45 degrees off axis, using the same r and magnetic dipole moment as the experiment. The value I calculated was 8.06 times 10 to the negative fourth Teslas, which is larger than my experimentally calculated value. To conclude, I'll answer a few questions. First, what if I hadn't oriented my experiment to compensate for magnetic north and instead laid out the meter stick at some intermediate angle with respect to Earth's magnetic field? How would the results have changed? If I had done this, then the magnetic fields that I would be calculating wouldn't be just due to my bar magnet. They would also include part of Earth's magnetic field, because everywhere on Earth, the Earth is producing some sort of magnetic field, and the reason we had to orient it in the direction so that the x component was 0 was so that we could ignore this component of Earth's magnetic field and just get the value due to our bar magnet. Now for the second question. What if I were to stick two identical magnets together end to end and run the experiment again? How would your measurements differ? If I were to do this, I would expect to calculate larger magnetic fields, because instead of there being just one magnet there would now be two.